I can tell you, a lot of us were up really late last night. We were watching the images come down one by one. By about 2 a.m. here, local time in Denver, we got what I call the money shot, where we saw tag SAM contacting the surface, and then the effect of injecting that high purity gas down into the asteroid regolith. So I think without further ado, let's just go and take a quick look at the data. I'm going to show you a series of images taken by the SAMCAM. This is about twice the frame rate, so we're coming in a little bit faster here. And I'm just going to let that play out. I'm going to let you appreciate it one more time as we go through. And then we've got some analysis that we can perform about what happened here. Maybe one more time. It's just so cool. I must have watched it about 100 times last night before I finally got a little bit of shut-eye. And then I dreamed of a wonder world of Bennu regolith particles floating all around me. So just to remind you what we're looking at here, this is a full-scale model of the tag SAM head. And so this is what's at the end of that long robotic arm. You can see it's about 30 centimeters or about a foot in diameter. And this is what we placed onto the surface of the asteroid. It's at the end of the robotic arm, and the high-purity nitrogen gas feeds in here through a couple tubes, and then it actually comes out through this inner annulus and pushes everything up into the collection chamber. Let's take another look at just a couple of the key images right before contact and right after contact before the gas is fired. So there's a little over 1 second time difference between these two images, and there's an enormous wealth of information about the asteroid surface contained in here. So the first thing that you can see, if you look at the area right above about the 12 o'clock position on the sample head, we're making contact with a relatively large rock, a little over 20 centimeters, which we had considered a potential obstruction to sampling, but literally we crushed it. When the spacecraft made contact, that rock appears to fragment and shatter, which is great news because that means that ingestible material by tag SAM is probably being created just by the motion of the spacecraft pushing into the surface. If you look at a couple other areas around, like this one here about 1030, just off to the upper left of the tag SAM head, you can actually see motion in the regolith. So it looks like we are pushing and exerting a force throughout this soil on the asteroid surface. Also good news for our potential for successful sample collection. I want to point out another feature of the tag SAM head that didn't get a lot of attention yesterday. We talked a lot about the gas stimulation and driving bulk sample into this filter. But as you can see in this 3D printed model of tag SAM, there's a whole series of circular discs. On the flight hardware, what's mounted in here are contact pads, literally made out of stainless steel Velcro. And these are designed to pick up material on the order of a millimeter size and smaller. So the fact that when the tag SAM head is making contact with the asteroid surface and it's crushing what appears to be a very soft, friable material is good news not only for the bulk sample collection, because in our laboratory tests, when the tag SAM head penetrates, and we're estimating about 2 centimeters of penetration at least during this event, a lot of material gets forced up into the sample collector. And of course, by crushing, you're going to drive a lot of material into these contact pads. So right away, bottom line is, from analysis of the images that we've gotten down so far, is that the sampling event went really well, as good as we could have imagined it would. And I think the chances that there's material inside the tag SAM head have gone way up based on the analysis of these images. We're going to take a look at just one more sequence now after the event when the gas bottle gets fired. You can see that particles are flying all over the place. We really did kind of make a mess on the surface of this asteroid, but it's a good mess. It's the kind of mess we were hoping for. Lots of material has been mobilized, giving us additional confidence that we actually pushed material up into the sampler head. And just a little bit of the timeline here. We made contact. About 1 second went by. The gas bottle fired. The gas was blown down for about 5 seconds, which is as much time as we were hoping to get to collect that material. So the system seems to have performed nominally. The surface of Bennu behaved very well. And so everything that we can see from these initial images indicates sampling success. We still have some work to do. We're going to go through our entire procedure, including what we'll hear from Sandy later in the day about the additional activities for sample verification. So in case you can't tell, I'm pretty excited about all of this. This is great news.